Welcome to this explainer. Today we're diving into a seriously fascinating scientific paper that attempts to solve a century of bizarre terrestrial mysteries using just one single, elegant theory. We're looking at brand new research that connects the absolute deepest corners of the cosmos directly to the weather in our own atmosphere. And honestly, the implications are mind-blowing. Let's just get right into it.
So what exactly do dark matter, ball lightning, human nuclear tests, and UFOs all have in common? I know. It sounds like the setup to a crazy science fiction story, right? Completely absurd. But believe it or not, this connection is actually grounded in a recently proposed, highly rigorous scientific framework. As we go through this explainer, you're going to see exactly how all of these seemingly unrelated anomalies are tightly woven together. We're starting our detective story with something called mysterious transients, or MTs for short. These are strange, sub-second flashes that were discovered on old photographic plates from the 1950s Palomar Sky Survey, and they display some incredibly bizarre, almost impossible characteristics that have honestly just puzzled astronomers for decades. They appear out of nowhere, vanish in less than 30 minutes, and sometimes they're perfectly aligned in a straight row right across the sky. But here is the craziest part. They are strongly correlated with the timing of human nuclear weapons tests, as well as distinct reports of unidentified anomalous phenomena, or UAPs. To really wrap our heads around just how weird this is, let's look at the math. The probability of just two of these transients randomly appearing in the same tiny box of the sky is roughly 10 to the negative sixth, literally 1 in a million, let alone finding them perfectly aligned in rows of 3 or 5 within a single photographic exposure. The math unequivocally tells us these aren't just random glitches on old film. Something very specific and very physical is actually causing them. To solve this, the research introduces a brilliant new culprit, axion quark nuggets, or AQNs. This is a radically different way of looking at dark matter. See, for over 40 years, scientists have basically hunted for WIMPs, weakly interacting massive particles. The old theory assumed dark matter was completely invisible, ghost-like, and weakly interacting, but AQNs, they are vastly different. We're talking about macroscopic chunks of actual nuclear density with dense matter or even antimatter cores. This makes them highly explosive when they encounter regular matter in Earth's atmosphere. And this brings us to a really cool concept the paper calls a chameleon behavior. Basically, these nuggets act as perfect standard dark matter out in the empty vacuum of deep space, totally invisible, silent, and non-interacting. But the moment they hit the dense, heavy environment of a planet or a star, they take off their disguise. They instantly become highly reactive, strongly interacting objects that unleash incredibly powerful effects on our environment. Just picture this, a macroscopic chunk of antimatter, compressed to the unimaginable density of a neutron star, slamming into our atmosphere at a blistering 200 kilometers per second. That's the typical speed of dark matter moving through our galaxy. And when an AQN hits our atmosphere moving that fast, well, things get very interesting very quickly. So how exactly does this collision build into an actual flash of light? It happens through a rapid, microsecond process called spallation. First, the high-speed AQN enters the atmosphere. Then, when it hits a region of highly ionized air, it triggers a chain reaction, like an avalanche instability. The intense heat and sudden electrical charge cause the nugget to rapidly fragment, or spall. Its antimatter core annihilates with the surrounding air, releasing a massive burst of X-rays. Finally, those invisible X-rays instantly excite the surrounding air molecules, producing that bright, visible optical flash recorded on those old photographic plates. Now you might be wondering, how does this explain those perfectly aligned flashes spanning right across the sky? Well, the massive parent nugget just keeps plowing forward in a straight line. It's incredibly heavy, so shedding a few fragments doesn't alter its trajectory at all. It just undergoes multiple spallation events along its path, dropping flashes of light like perfectly aligned breadcrumbs. Meanwhile, the smaller secondary AQNs break off from the main body, slow down dramatically as they hit the lower atmosphere, and actually fall toward the ground in a matter of seconds. But wait, we have to talk about the absolute strangest clue in this whole detective story. Why on earth did these flashes spike heavily around the exact dates of nuclear tests? I mean, how does a dark matter nugget flying in from deep space care if a nuclear bomb went off down here on Earth? What could possibly connect the two? The crucial unifying thread here is highly ionized air. Remember that spallation process we just talked about? The AQN actually requires highly ionized air to trigger that explosive chain reaction. Thunderstorms naturally ionize the atmosphere, but humans also artificially ionize the atmosphere. Nuclear tests leave the air heavily ionized for days, even weeks, due to the radioactive fallout and beta decay left lingering long after the initial blast. This is truly the ultimate aha moment of this explainer. The exact same highly ionized air that triggers ball lightning during a thunderstorm is artificially created by nuclear fallout. This charged air acts like an invisible trigger. When a dark matter nugget flies through the fallout of a nuclear test, that ionized air drastically increases the likelihood of it exploding into those mysterious transients. And on the flip side, when the smaller secondary fragments fall to the ground during a naturally charged thunderstorm, human observers have historically recorded them as ball lightning. Speaking of ball lightning, there is a truly wild detail from the source material I have to share. Scientists once rigorously investigated an event where a large 20-centimeter glowing ball of lightning passed straight through a solid glass window. But when they analyzed the glass, it hadn't shattered. Instead, they found a microscopic 0.24 millimeter cavity melted perfectly straight through the solid pane. Just think about that for a second. How does a massive 20-centimeter ball squeeze through a microscopic hole? Well, the AQN theory solves this glass mystery perfectly. That visible 20-centimeter glow of the ball lightning, it's basically an illusion. It's simply the distance that X-rays from a tiny secondary AQN travel through the thin air before creating a visible glow. The actual physical secondary AQN hidden at the center is microscopic. When that tiny antimatter core hits dense solid glass, the X-rays don't travel 20 centimeters, they travel exactly 0.25 millimeters. The immense energy instantly melts a microscopic hole, and the tiny core slips right through without shattering the pane. The physics for both air and glass line up flawlessly. Which brings us to our final mystery, UAPs. Specifically, the terrifying green fireballs that were frequently observed near nuclear sites back in late 1948. They completely baffled astronomers like Lincoln La Paz. He noted that their trajectories were too flat, their color was way too green, and incredibly, absolutely no meteoritic material was ever recovered. They acted absolutely nothing like normal space rocks. According to the source material, these specific UAPs are definitely not extraterrestrial craft, and they certainly aren't meteors. They are actually just larger, fast-moving AQNs that haven't stopped yet. Their terrifying visible size is, once again, just that massive glowing radius of X-ray emissions interacting with the atmosphere. There's no sound because the actual physical core pushing through the air is microscopic. It doesn't displace enough air to make a sonic boom. The vivid green color comes from complex ionization of the air. And most importantly, because their core is antimatter, they annihilate surrounding soil upon impact, leaving absolutely zero meteorite debris behind. This framework neatly explains bizarre, really well-documented events like the 2003 Elma fireball in Washington state. An incredibly bright fireball was actually seen hitting the ground, but when investigators got to the impact site, no meteorite, no alien debris. All they found were extremely hot, glassy black rocks with the exact chemical composition of the surrounding dirt. This perfectly aligns with our theory. The AQN's antimatter core simply annihilated the local matter on impact, melting the soil into hot glass through sheer concentrated energy. And listen, this isn't just a fun speculative theory. The mathematics scale beautifully. Based on the established density of dark matter in our galaxy, the paper predicts there should have been roughly 840 of these AQN atmospheric hits over a 7-year period above the Palomar Observatory. When the researchers factored in the specific times the air was artificially ionized by nuclear testing, this statistical prediction perfectly matched the historical, clustered photographic evidence they actually found in the archives. It is a stunning correlation. So what you should ultimately take away from this explainer is pretty profound. We don't necessarily have to point our multi-billion-dollar telescopes exclusively into deep space to find dark matter. We can literally use the Earth itself as a giant dark matter detector. We can use distributed acoustic sensing, basically fiber optics, to listen for AQN infrasound tracks beneath the surface. We can use networks of all-sky cameras to monitor low-altitude optical flashes. The paper even suggests the Large Hadron Collider's ultra-vacuum pipe can act as a massive broadband acoustic detector to listen for these invisible nuggets just harmlessly passing right through the Earth. This framework completely changes how we view the universe. It beautifully connects the absolute largest mysteries of the cosmos with the weather happening right in our own backyards. And it leaves us with one incredible lingering question to ponder. Will our ultimate proof of dark matter come from a telescope pointed at a distant galaxy or from a thunderstorm right here on Earth? Thank you so much for exploring this fascinating framework with me. Keep looking up and stay curious.